Welcome back to 3 Inquisitive Kids. In this video, we are going to use different trig identities and formulas to help us simplify expressions. Here is problem 1. Calculate cosine of 25 pi over 3 plus tangent of negative 15 pi over 4. To solve this problem, we can apply the periodic formulas. And the two that we're going to be using is the cosine and the tangent periodic formula, which states that cosine of theta plus 2 pi n is equal to cosine of theta, and that tangent of theta plus pi n is equal to tangent of theta. Here, n is an integer. How does this work? Well, if we were to visualize the graph of, say, a cosine function, something like this, we know that there's periods. So, for example, the value of this point and the value of this point, one period later, is the same value. So it's just saying that if you move forward or back a whole period, you're going to land on the same point. Now, let's apply this to our problem. Cosine of 25 pi over 3 is the same thing as 6 over 3 pi plus 6 pi over 3 plus 6 pi over 3 plus 6 pi over 3 plus pi over 3. And tangent of negative 15 pi over 4 is the same thing as negative 15 pi over 4, and then we can just keep adding on 2 pi. So plus 8 pi over 4 plus 8 pi over 4 until we get to a positive value. Now, if we continue simplifying, since all of these are just 2 pi's, they cancel out, because if any multiple of 2 pi is being added onto theta, then it's the same value as just cosine of that value. So here theta is pi over 3, and here this expression is equivalent to tangent of positive pi over 4. Both of these we can use a unit circle reference to help us out. Cosine of pi over 3 is 1/2. And the tangent at pi over 4, which is 45 degrees, is equal to 1. So in the end, this expression simplifies to 3/2, and that is our answer. Now let's take a look at B. In addition to the cosine and tangent periodic formulas, we're going to be looking at sine of theta plus 2 pi n, where n is an integer, is equal to sine of theta, and cotan of theta plus pi n is equal to cotan of theta. Again, n is an integer. Well, here the first thing we can see is the problem gives us all the values in degrees, not radians. But we can easily convert radians into degrees. The sine formula says theta plus any multiple of 2 pi. But we know that 2 pi is really 360 degrees. So any multiple of 360 degrees. Therefore, we can rewrite sine of 810 as 360 plus 360 plus 90. And here for cotan, it's any multiple of pi n, and pi radians is 180 degrees. Therefore, this can be rewritten as theta plus an integer multiple of 180. So cotan of 765 is 180 times 4 plus 45. And for tangent, we have negative 1,125 degrees. But using this equation up here, we can keep adding on multiples of 2 pi, or we can keep adding on multiples of 360. So we would have negative 1,125 plus 360 times 4. That's when it will become positive. And for cosine, negative 450. Well, the cosine formula says that we can keep adding on multiples of 2 pi radians, or we can keep adding on multiples of 360. To simplify the tangent, we can keep adding on 8 180s onto negative 1,125. And for the cosine, it says that we can add on multiples of 360 degrees. Negative 450 plus 360 times 2 would give us a positive value. Now let's simplify. Well, we know that the 360s just can cancel out, and this is the same as just sine of 90 because of the periodic formula. And cotan, well, 180s can cancel out, so we have cotan of 45 degrees plus tangent of, simplify the expression on the inside here, and we have 315. And finally, the cosine value gives us cosine of 270. Now, these are all common degrees that we can use a unit circle reference to help us out with. We know that sine of 90 degrees is the y-coordinate of the point on the unit circle in which we have a degree of 90 degrees. So that is 1. The cotan of 45 degrees is just the reciprocal of the tangent at 45 degrees, which is 1. The tangent of 315 degrees is negative 1. And the cosine at 270 degrees is 0. Therefore, our end answer is 1. Now here is C and D. We're still going to be using the periodic formulas. Cosine of negative 585 degrees. We can turn that into a positive value by adding on multiples of 360 to negative 585. So if we had negative 585 and we added 2 360s to it, we would get a positive number. And on the bottom, we have sine of a radian value. Well, we can simplify this by taking away multiples of 2 pi. Also on the bottom, we have sine of negative 570. And negative 570, we can get turned into a positive value by adding on multiples of 360. Now, our expression would be cosine of 135 degrees over sine of 3/4 pi plus sine of 150 degrees. So the cosine of 135 degrees is negative square root of 2 over 2. And the sine at 3/4 pi is equal to the square root of 2 over 2. The sine at 150 degrees is equal to 1/2. Now we can simplify this by doing negative square root of 2 over 2 times 2 over 1 plus square root of 2. That cancels out. And then we have negative square root of 2 over square root of 2 plus 1. And then we simplify by rationalizing the denominator. We can multiply square root of 2 minus 1 on both the top and bottom. And that gives us negative 2 minus the square root of 2 over 2 minus 1. So in the end, we have square root of 2 minus 2. Given that sine of alpha plus pi is equal to 4/5, and that the product of sine of alpha and cosine of alpha is less than 0, find the value of this expression. Let's first look at the conditions we are given. Let's visualize this. In this case, pi just means an additional 180 degrees. So if we were to visualize any angle on the unit circle, let's say this is angle A, and this is its sine of alpha. Well, if we add any 180 degrees to any angle, we will always have this line. So the sine will have the same absolute value, but a different sign. From this, we know that the condition is sine of alpha is equal to negative 4/5. Now that we have sine of alpha, we can also find the cosine of alpha, because we know that the sine squared of alpha plus the cosine squared of alpha has to equal 1. Therefore, 16 over 25 plus the cosine squared of alpha is equal to 1. So this here would be 9 over 25. Now we take the square root of that, which is 3 over 5. And we know it has to be 3 over 5 because a negative and a positive multiplies to be another negative. And cosine has to be positive in order for the product of sine and cosine to be negative. So just by looking at the condition that we are given, we already have a lot of information. Now let's take a look at the actual expression and see how we can simplify it. We already know that on the top part, sine of a minus pi, whether you plus 180 degrees or minus 180 degrees to any angle, the sign you get from that is always the opposite. So the opposite of negative 4/5 is 4/5. Therefore, on the top we have 2 times 4 over 5 plus 3 times, and then we have the tangent of 3 pi minus a. The plus 3 times tangent of 3 pi minus alpha will become negative 3 sine of alpha over sine of pi over 2 plus alpha. And on the denominator, we have negative 4, and on the denominator, if we were to convert cosine into sine, we have negative 4 times sine of pi over 2 plus alpha. And as you can see on the bottom, sine of pi over 2 plus alpha is the same thing as cosine of alpha. So on the bottom, we have that to a cosine. And on the top, if we simplify a little bit, we have 8/5 minus 3 times sine alpha over cosine alpha. Now, all we have to do is substitute the values we got from earlier. 8/5 minus 3 times sine alpha is negative 12 over 5. So plus 12 over 5 divided by cosine of alpha, which is 3/5. And on the denominator, we have negative 4 times 3/5. Now, if we continue adding, 8/5 plus 4 over negative 12 over 5. This is equal to 28 over 8 divided by negative 12 over 5. Or if we just switch it into its reciprocal, times negative 5 over 12. Now here we can cross simplify, and we are left 28 over 5. And we are multiplying that with the reciprocal of 12/5, which is 5/12. If we cancel this out, we have negative 7/3 as our final answer.